Hello everyone. In this video we're going to be solving a system of ordinary differential equations. As I promised earlier, I'm going to try to give you at least once a week of these equations, systems, and so on and so forth. So we have x double prime equals y minus x plus t, and y double prime equals x minus y plus t. And we're going to be solving for x and y values. Quick reminder, x and y are functions of t. Great, so let's go ahead and see how we can solve a problem like this. Now, what makes this problem a tiny bit more difficult than the other ones we've done before is we have the second derivatives, not the first derivatives. That's why I want to make this gradually harder. So let's go ahead and start by adding these two equations. Now, when you go ahead and add these, you're going to realize that the y's cancel out and the x's cancel out. So you're going to end up with something like x double prime plus y double prime is equal to t plus t, which is 2t. This is great because we don't have any x and y in the equation. We can definitely take advantage of this. So in order to write this as the derivative of a single thing, let's go ahead and write this as the derivative of x plus y. Of course, that would be the second derivative, right? And so we can kind of write it like this. And now we're going to use substitution. Obviously, for these kinds of equations where we have really good symmetry, we can go ahead and take advantage of two things. One of them is call x plus y u. And then you can basically look at an equation like this, as simple as u double prime is equal to 2t. Great. Now, since x and y are both functions of t, u is also going to be a function of t. Now, you have a function of t whose second derivative is 2t. So what is that supposed to mean? Well, if you integrate twice, you're going to get u up to some constant, obviously. So let's go ahead and integrate once, u prime, the derivative. If you differentiate the first derivative, you get the second derivative. If you integrate the second derivative, you get the first derivative. So integrating 2t gives us t squared. Of course, there needs to be a constant added. And then we're going to integrate once more to get u. And if you integrate t squared, remember the power rule, you add and divide by that. And then c is just going to turn into c2. And then we're going to need another constant. Now, in this case, you can, I guess, use c1 for this and then c2 for the second constant. Make sense? Awesome. Now, we got u. And let's go ahead and save it for future use because you don't know how you're going to use it, right? Maybe you do. Now, we did get the sum as a function of t. Now, why don't we try to do something for the difference, right? The good thing about differences is that the t is going to cancel out. Notice that t minus t is equal to 0. So let's go ahead and rewrite this. X double prime is equal to y minus x plus t. Y double prime is equal to x minus y plus t. So here's what we're going to do. We're going to go ahead and negate the second equation and add, which means we're going to subtract these two things, right? And from here we get x double prime minus y double prime is equal to y. Now, in this case, the y's and x's do not cancel out. Obviously, they're just going to double. So we're going to get something like 2y minus 2x. And of course, the t's are going to cancel out. Great. Now, we have the second derivative of x minus y on the left-hand side. But what about the right-hand side? Well, it is actually the negative 2 times the difference x minus y. So let's go ahead and name this something. How about v? All right, u and v are pretty standard when it comes to this method. So now we get v double prime is equal to negative 2v. Well, this actually is going to turn into a homogeneous equation. If you add 2v to both sides, you'll get v double prime plus 2v is equal to 0. And as you know, we have a characteristic equation. If you replace v with e to the power kt, you're going to get, or rt, you're going to get something like this. R squared plus 2 is equal to 0. And from here, the roots are going to be square root of 2i and negative square root of 2i. And of course, since the roots are as e to the power something t, or rt, you can now write the v as c3, because we already used c1 and c2, right? c3 times e to the power root 2it plus c4 times e to the power negative root 2it. Great. Since this is homogeneous, this will be the whole thing. Now we got v and u, and how can we solve for x and y from here? Now, if you consider the fact that x plus y is equal to u, and x minus y is equal to v, here's what we can do. We can actually go ahead and add these two equations. That gives us 2x equals u plus v. And then from here, we can actually, extract or recover x as u plus v divided by 2. Awesome. And similarly, if you go ahead and subtract these two equations, you're going to get something like the x's are going to cancel out. You're going to get 2y is equal to u minus v. So y is going to be u minus v divided by 2. Now, by using the results for u and v, you can actually go ahead and recover x and y from here. Let's go ahead and do that. And I just want to maybe just take that expression and copy that over here. U is equal to t cubed divided by 3 plus t, I think there was a constant there, right? Some type of c2 something, c1t plus c2 plus c1t plus c2. This is u, and v is right there. So we can go ahead and now add these two expressions, right? And when we do, we're going to get something like this. Of course, there's going to be a 1/2 in the front, so we can go ahead and put that 1/2 here. And then u and v will be added. So we're going to get something like t cubed over 3 plus c1t plus c2. And then we're going to add the v in there, which is going to be plus c3 e to the power root 2it plus c4 e to the power negative root 2it. Awesome. That's going to be the value of x. And then we can recover y similarly. We just need to subtract. 1/2 is going to be in the front. We get t cubed over 3 plus c1t. Obviously, I don't want it to look like that. And then plus c2. And now you got to remember that you're subtracting v from here. So it's going to be like minus c3 e to the power root 2it minus c4 e to the power negative root 2it. And that should give you the solution. But one thing that I should talk about, because if you try to do this with any type of AI and maybe Wolfram Alpha, you're going to get similar but different looking solutions. I mean, I shouldn't say similar, actually. You should get the exact same solution, but expressed in a different way. Why? Let's go ahead and take a look. If you consider Euler's formula, what did Euler say? Well, he said many years ago, e to the I theta is equal to cosine theta plus I sine theta, which is obviously the most beautiful equation in the world, right, in math. Now, if you apply it to the scenario, e to the power I times root 2t, because that's what it looks like, right, in this format, it's going to be like cosine of theta. So this is going to be our theta now. Take a look at it. This is going to be our angle or argument. We're going to write it as cosine of root 2t. And of course, there's going to be a constant in front of it, right? So you kind of need to consider that as well. If you multiply that, in this case, it's multiplied by c3. So you can kind of put a c3 here, which means you're going to have a c3 here. And then cosine of, and I will probably just move this a little bit this way, c3 times cosine of root 2t plus I times sine of root 2t, right? And then you can definitely do the same thing for the negative I root 2t. And then you can kind of put these together if you want, because what's going to happen with that, c3, let me show you real quick. When you do the same thing with the minus sign, you're going to have a c4, and you're going to have the cosine of negative root 2t, which is the same as that, by the way, and then plus I times sine of negative root 2t. And guess what you can do from here? You can actually go ahead and, because cosine is an even function, you can actually go ahead and put these two together. This is going to be a positive sign. And you can name c3 plus c4 just another constant. Definitely, there's a way to write this a little bit differently. You can also absorb this I into the other constant. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.